Okay, tonight's video is about Newton's second law, which we will get to in just a second. Before we do it, you need to understand net force. And this is not a hard concept. It's kind of been there in the background as we've been working this whole unit. So here we go on net force. Again, not a hard concept. First off, in this video, and you may want to make a note of this, I'm going to treat the up as the positive y. So anytime something's pointing up, that's positive y, and then pointing down would be negative y. And I'm going to call pointing to the right positive x. Therefore, pointing to the left would be negative x. So I just need to declare that coordinate system before I get started. Okay, we're going to look at each of these three examples and find the net force in each one. First here we have what looks like a box or an inkwell, and it has 5 newtons to the right and 10 newtons to the right. So that would be 5 newtons in positive x and 10 newtons in positive x, which gives me a positive 15 newtons. Here, on the second example, we have 5 newtons to the left, so that would be negative 5 newtons in x, and 10 newtons to the right, positive 10 newtons. Therefore, our net force is 5 newtons. This is a lot like displacement, you might have noticed. So like in the first one, if I went 5 to the right and another 10 to the right, my displacement would be 15 to the right. On the second one, if I went 5 to the left and 10 to the right, my displacement would be 5 to the right. Final example, I've got 5 newtons to the left, that's negative 5 newtons in x, and 5 newtons to the right, that's positive 5 newtons in x, for a net force of 0 newtons. Okay. So finding net force is just adding your forces, including their directions. So if they're negative, you keep them negative, positive, positive, and you add them together. You can also do this in y, and it works the same way. It doesn't just have to be in x, like these three examples were. All right, Newton's second law. Newton's second law is net force equals mass times acceleration. And this should really be written more as a subscript. F net equals ma. My iPad messed up. Anytime you have a net force, which means unbalanced forces, an unbalanced force causes a mass to accelerate. And in fact, that's exactly what this equation says. An unbalanced force causes a mass, m, to accelerate, a. The equation says exactly what it means. A non-zero net force causes acceleration. F net is the sum of all the forces. M, or is the mass, measured in kilograms, and A is acceleration. I'm going to go ahead and rewrite this equation for both x and y, because I feel like in the first unit in kinematics, people were going along with one set of equations, and then suddenly we split them up into x and y, and people got confused. So what I'm going to do is go ahead and write this equation for forces in x and forces in y. Because remember, we're thinking of the world now in physics in x's and in y's. So we can go ahead and split everything up. Here's what that would look like. Net forces in x, so the sum of all x forces, equals mass times the acceleration in x. And then for y, net forces in y equal mass times the acceleration in y. So when solving Newton's second law problems, you'll always be looking at net force in x and net force in y. We don't have the math skills yet to use net force at an angle unless we split it into x and y. So if this were a net force here, I would have to get the x component of the net force. Sorry, that's the y that I just drew. I'd have to get the y component of the net force and the x component of the net force before I could use it. And that's just a simple job for sines and cosines. Problems with Newton's second law can get really complicated, but they all come back to this equation, F net equals ma. So if you know that equation, they will always come back to that, F net equals ma. No matter how hard they get, that's at the base of all of them. F net equals mass times acceleration.